In this video, I'm going to talk to you about how to interpret the graph on the right side with the following 4 questions. So taking a look at this distance versus time graph, the first question that I'm asked is to identify the domain. Now the domain is the set of your inputs, which is all the x values that your graph has. So what we want to do is look at our x-axis here, and I want to look at the left most point on the graph and what that value is, and the right most value on that graph, whatever that value is, that's what we're going to record. Now notice how this graph is not a set of points, and so because it's a continuous function, we want to represent our domain with an interval and not a set of points. So your interval should look something like this: a left number, a less than or equal to sign x, a less than or equal to sign to the right number. And you'll pick your sign based on whether your point is filled in, which would use the equal to, filled in the equal to, or not equal to. If there's kind of like an open dot, we would use strictly less than. So the leftmost x value recorded for this point would be 0. And it is equal to here, and it travels all the way to the right, and the rightmost point is past 14. That would be the number 15, and again that point is equal to here for my x value, and so that would be the left to the right, the distance that your values for x span. Now the range is your output, so this is your set of your outputs, which is the y values. And so you almost can kind of turn your paper, and what we're going to really do is focus on the y-axis here, and what is the lowest value that your y-axis has, the lowest point to the highest point. So I did kind of do this in my last video, but your curtains would be your x values. So looking at my x value, the lowest is 0 here, and to the right it was 15. But now for your outputs, you want to do low to high. So I'm noticing there are 2 points here with a y value. So I'm only looking at my y-axis. The lowest 2 points on the graph would start at 0. And then the graph goes higher, 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 higher. How high does the graph go? The highest point that looks like my graph would reach is in between 22 and 26. So I would roughly estimate that at 24. And that looks like it would be the highest point on the graph. So according to my y-axis, the lowest point is 0 for a y value. And on the y-axis, the highest that our graph reaches is 24. Now it looks like this is equal to 24 because there is a line up here at 24, and it would look like equal to 0, so I'm going to use the less than or equal to symbols for that. And it will always go for a continuous function, left to right for your x values, and lowest to highest, meaning how far down does it go? How far up does your graph go? That's kind of the 4 areas of your graph: left, right, up, and down. You cover all 4 with your domain and range. Now for the next question here, it says C, identify the intervals where your function is increasing. That means where your function is going up. And I notice our function is going up in this distance. Now what I'm going to do is label that with domain. And I'm going to say, from what values from what x values does that graph go up? And it looks like on my x-axis, between 0 and 5, because it's in between 4 and 6, between 0 and 5 is where our graph is going upwards. So I'm going to put from 0 for an x value to 5 for an x value, our graph goes up. Then it remains constant, so I'm not going to label that part. Then it goes down, so I'm not going to label that. This is constant, and this is also going down, so the only section where it's going to go up is this first piece of our graph. And then the last question here says identify the intervals, maybe interval or intervals, so it looks like there may be 2 here because we noticed that there are 2 places where our graph goes down, and that would be in this section here, so let me actually just highlight this piece here. From this section here and this section here, we're gonna label those two intervals. And again, I'm gonna use my inputs to talk about that. So as I'm pulling out my curtains, this makes it a little easier for me. So it looks like our starting point would be roughly at this number 9. And the end point for where that graph is going down in this section looks like it would be 11. So in that section of our graph, the function is going downward. So from 9 to 11, and now again it's going to go down, but more to the right here. So how far to the right? It looks like that starting place would be 13 on the x-axis and all the way to the end of the graph, which would be 15. So between those x values, the graph is going down. So from 13 to 15. The sections that we didn't label were the sections that were increasing. So increasing happens really from your 4 to your 9. That's that section that we're missing in here. And then between 11 and 13 here is also an constant section. So if they had said constant, we'd have these two intervals from 5 to 9. And then also between these two decreasing sections, there was a tiny section that was constant as well. And that's in between here, your 11 to your 13. So these 5 pieces make up your graph. The increasing section here, the constant section here, decreasing came next, then another constant section here, and then last decreasing.